Hello everyone, welcome to my channel GVS Chem. In this video, I am going to explain cells and batteries and numericals. Please subscribe to my channel, like, share and comment my videos.
Now let us see the batteries. Battery means it is a electrochemical cell. Electrochemical cell is the device used to convert chemical energy into electrical energy. Batteries are of two types: primary cells and secondary cells. One is primary cells. Primary cells means the cells which are used only for once. That is, the chemicals exhausted in the cell is completed. If the chemicals are exhausted, the cell is thrown out. That means it is only once used. The second one is secondary cells. Secondary cells are rechargeable cells. They are used again and again. Now let us see the primary cells. Primary cells. The most important one is dry cell. You have seen already the dry cell is used in wall clocks and transistors, tape recorders, etc. So the dry cell, it has this is dry cell. This is zinc container. Zinc container itself is used as anode. Zinc container itself is used as anode, and the graphite rod. This is the graphite rod. Graphite rod is in the middle of the zinc container. Graphite rod is used as a cathode. Now, in between this is a zinc. The graphite rod is surrounded by the mixture of manganese oxide and carbon. Carbon means graphite powder. In between the manganese oxide and the carbon powder, in between the zinc container and manganese oxide and carbon, the paste of product ammonium chloride and zinc chloride is used. Ammonium chloride and zinc chloride is filled. So this is the construction of the cell. Now let us see the reactions of cell. Reactions of the cell. Reaction at anode. Reaction at cathode. Reaction at cathode. At cathode, MnO2 manganese oxide plus NH4 plus electron. We get manganese hydroxy oxide plus NH3. Ammonia gas is released. Now reaction at anode. Zinc gives zinc ion plus 2 electrons. Now the overall reaction is zinc 2 plus 2 NH3 gives zinc NH3 taken twice. So a complex ion is formed, that is diamine zinc 2 plus ion complex ion is formed in the overall reaction. So this is the dry cell. Dry cell is nothing but primary cell. Primary cell is used only once, that is chemicals are exhausted, the cell is thrown away. So it contains zinc container which acts as anode, and graphite rod acts as cathode. In between, the graphite rod is covered with mixture of manganese oxide and carbon, and in between this and zinc container there is a trace of ammonium chloride and chloride and zinc. Ammonium chloride and zinc chloride. Now these are the reactions taking place at cathode and anode. Now let us see the mercury cell. Mercury cell. Mercury cell, nowadays mercury cells are used in wristwatches, video cameras, etc. These are the miniature cell. The cell has a zinc mercury amalgam, and of course it is filled here. This is in the anode cap. Cathode is a paste of mercury oxide and carbon. This is filled with mercury oxide and carbon, and the electrolyte is a moist paste of potassium hydroxide and zinc oxide. Electrolyte is potassium hydroxide and zinc oxide. Now let us see the reactions. Reaction at anode. Zinc combines with OH to form zinc oxide and water. Of course, 2 electrons are released. Now reaction at cathode. Reaction at cathode. Now reaction cathode, HgO combines with water to form Hg and 2OH minus, and of course 2 electrons are taken here. Now the overall reaction is zinc Hg plus 2OH 2OH get cancelled, and water HgO plus water gives zinc oxide solid plus Hg. So this is the overall reaction in a mercury cell. So these are the cells. These are the primary cells. Now let us discuss the secondary cells. Primary cells means primary cells are those which can be used at only once. Dry cell and mercury cell are primary cells. Secondary cells are those which can be used, which can be recharged again and again. They are used in vehicles. Now let us discuss the secondary cells. Secondary cells. Secondary cells means rechargeable cells. Rechargeable cells. The most important cell is lead storage battery. Lead storage battery. In this lead storage battery, these are the sheets which are darkened. They are spongy leads. Spongy lead. These spongy lead sheets, they are used as anode. Spongy lead sheets are used as anode, and cathode grid of lead sheets which are deposited with lead dioxide PbO2. 38% of sulfuric acid is used as 38% of sulfuric acid is used as electrolyte. So this is the setup of lead storage battery. In the lead storage battery, 6 cells are connected in series, and each cell gives 2 volts potential difference. Totally, the total potential difference obtained from this cell is 12 volts. So this is a 12 volt battery. Now let us see the reactions taking place during this charging and discharging. Reactions taking place during charging. At anode, Pb plus SO4 2 minus gives PbSO4 plus 2 electrons released. Lead combines with that anode, lead combines with sulfate, and lead sulfate is formed, and of course 2 electrons are released, and E0 reduction is equal to 0.36 volt. Now at cathode PbO2 SO4 2 minus plus 4H plus 2 electrons gives PbSO4 plus 2H2O E naught equal to 1.69 voltage. Now the overall reaction is Pb plus PbO2 plus sulfate, 2 sulfate ions are there, 2 sulfate ions plus 4H plus gives PbSO4 plus 2H2O. Now if you add this, E naught reduction equal to 2.05 volt. So this is charging. As the cell is continuously working, the concentration of sulfuric acid decreases and PbO2 coats on the electrodes. So during working of the cell, the concentration of sulfuric acid decreases as sulfate ions are consumed to form lead sulfate, and of course lead sulfate coated on electrodes. So with decrease in concentration, density of the solution, that is sulfuric acid, decreases. Therefore, when the density reaches a certain minimum value, again charging should be done. The density of the cell can be checked very easily. Now let us see the charging. During charging, the reactions we have to write here. This is anode, so write this reaction in a reverse manner to get a cathode. So therefore, now let us see the reactions involved during the charging. At cathode, PbSO4 plus 2 electrons gives Pb plus SO4 2 minus. Now at anode, PbSO4 plus 2H2O gives, this is in aqueous status and of course this is in liquid state, Pb plus PbO2, both are in solid state, 4H plus aqueous plus 2 electrons. Now the overall reaction is, at anode, PbSO4 plus 2H2O gives PbO2 plus 4H plus 2 electrons plus sulfate. So lead sulfate plus water gives sulfate ion plus PbO2 plus 4H plus 2 electrons. Now the overall reaction is PbSO4 2 molecules are there, PbSO4 plus 2H2O gives, of course Pb here, Pb solid plus PbO2 solid plus SO4, 2 sulfate ions are there, sulfate ions plus 4H plus. Here 2 electrons consumed, 2 electrons released, therefore electrons are not necessary to write. So to enhance the output of the cell, the anode plates and cathode plates are alternately fixed one after the other, and of course both are separated by insulating material. Anode plates and cathode plates are separately connected so that the output increases. So this is the lead storage battery charging and discharging. Now another secondary cell is lithium ion battery. Nowadays the lithium ion batteries are widely used in cell phones, watches, electronic gadgets like laptop, tabs, etc. In lithium ion battery, graphite is anode and layered oxide of lithium, that is lithium cobalt oxide. Lithium cobalt oxide is used as cathode. Lithium cobalt oxide is used as a cathode, and graphite is used as a anode. And electrolyte is lithium perchlorate. Lithium perchlorate, LiClO4, lithium perchlorate. Now the reactions involved in this reactions involved is at the anode, lithium cobalt oxide. So lithium cobalt oxide, lithium 122 cobalt, this is cobalt oxide, plus lithium solid plus X electrons. So this is the reaction at anode. Lithium cobalt oxide gives lithium cobalt oxide. 1 or 2 lithium atoms are involved. X lithium ions and X electrons are released. So at anode, X lithium plus X electrons plus 6 carbons. Carbons means from anode. Graphite is there, no? So it combines with the graphite. So this becomes LiX C6, lithium carbide. Lithium carbide is formed. So this is the lithium ion battery. Lithium ion batteries are widely used in cell phones, cells, laptops, etc. And nowadays lithium ion batteries are used in electric vehicles also. The most important task is of the lithium ion battery is it is used in electric vehicles.
Now let us discuss some questions. A device that converts chemical energy into electrical energy is called A. Generator, B. Electrochemical cell, C. Alternative cell, and D. Electrolyte. The correct answer is B. So correct option is B. Next, solar cell working principle is photovoltaic effect, thermoelectric effect, photoconductive effect, and Seebeck effect. The correct option is A, that is photovoltaic effect. The density of lead sulfate decreases during A. Charging, B. Discharging, both charging and discharging, and none of these. The correct option is B, that is discharging. During discharging, the density of H2SO4 decreases during discharging. So the correct option is B. In the dry cell, electrolyte used is zinc chloride, NH4OH, C. Paste of NH4OH and KOH, paste of NH4OH and zinc chloride. The correct option is paste of NH4OH and zinc chloride. So the correct option is zinc. That is now the fifth question is, how many cells are connected in series to make a 12 volt battery? A 4, B 5, C 6, D 10. Our correct option is C. Which of the following is used as electrolyte in the fuel cell? The options are KOH, NH4OH, ammonium hydroxide, ferric hydroxide, and copper hydroxide. The correct option is A, that is KOH. Which of the following is not produced in the fuel cell? Electricity, B. Pollutants, C. Heat, and D. Water. Pollutants are not produced in the fuel cell. Therefore, the correct option is B. Pollutants. Now let us do one problem. In the button cells widely used, In the button cells widely used in watches and other devices, the following reaction takes place. Zinc plus silver oxide plus water gives zinc 2 plus Ag solid and 2 OH minus. Determine the delta or G naught for the reaction provided E naught for the reaction is 1.104 volts. Now let us see the solution. See how many electrons are involved here. Zinc becomes zinc 2 plus. Therefore, the number of electrons involved is 2 electrons. N is 2. Now we know that delta or G naught is equal to minus N of E naught cell, where N is number of electrons, F is Faraday constant, that is 96,500 coulombs, and E naught is voltage for the reaction, that is 1.104. Therefore, substituting all these values here, minus 2 into 96,500 into 1.104. So this becomes minus 213072 joules. Here minus sign indicates the free energy available. So finally we don't write the minus sign. Therefore, if joules are converted into kilojoules, 1 kilojoule equal 1000 joules. So dividing this with 1000, we get 213.072 kilojoules.